Hello students, welcome to Diksha Karnataka YouTube channel. Abhyas KCET 2024 mock test 4 has been released on Monday. In this video, I'm going to discuss the solutions of this test, mock test 4, the part 2, question number 151 to 180. Question number 121 to 150 done by Karthik sir, the part 1. Okay, so if you haven't downloaded the paper, join the WhatsApp channel. In there, you will get the question paper. Okay, use the link which is given in the description box. Okay, so let's start to solve the questions. Question number 151. A short circuited coil is placed in a time varying magnetic field, that is dB by dt, right? dB by dt. The current induced in the coil, electrical power is dissipated due to the current induced in the coil. If the number of turns were to be quadrupled, that is n dash is equal to 4n or n2 equal to 4n, okay? n2 equal to 4 times n1. n1 is the initial number of turns in the coil, n2 is the new number of turns in the coil, and the wire radius halved, that is r2 equal to r1 divided by 2. r1 is the initial radius of the wire, r2 is the new radius of the wire. The electrical power dissipated would be, okay, so we need to find electrical power dissipated, right? So P, that is electrical power dissipated, P equal to E square divided by R. So what is E? E is induced EMF, okay? R is resistance of the coil. So what is induced EMF? Induced EMF is equal to rate of change of magnetic flux, right? Rate of change of magnetic flux. Phi is magnetic flux, okay, d phi is change in magnetic flux. So phi, that is magnetic flux, is equal to n into b into a, right? Actually n into b into a cos theta, theta is angle between magnetic field vector, that is b, and area vector a, right? The angle between b and a is 0 degree because both are in same direction, right? Both are in same direction. So that's why the theta is 0 degree, cos 0 degree is 1. So phi equal to n into b into a, right? So now E, that is induced EMF, is equal to n into a into dB by dt, right? dB by dt. dB by dt. We know that resistance R is equal to rho into L divided by pi into R square, right? What is rho? Rho is resistivity. What is L? L is the length of the wire, right? And pi R square is area of the cross section of the wire, right? So now here power dissipated, P is equal to E square, right? E square is n square a square into dB by dt whole square, whole divided by rho into L divided by pi into R square, right? Rho into L divided by pi into R square. So now from this we can conclude that power dissipated, electrical power dissipated, is directly proportional to n square R square divided by L, right? Electrical power dissipated is directly proportional to n square R square by L, right? Here the number of turns increased, right? Isn't it? So we need more wire, right? So the length of the wire is also increased, right? How much it increased? So it increased 4 times, right? L2 equal to 4 times L1, isn't it? So now we need to find electrical power dissipated. So P2 divided by P1 is equal to, P2 is N2 square R2 square divided by L2, right? So N2 square is 4 times N1 square, that is 16 N1 square, right? And R2 square is R1 divided by 2 whole square. R1 divided by 2 whole square is R1 square divided by 4 whole divided by L2. L2 is 4 times L1, right? 4 times L1 whole divided by Next P1 is N1 square R1 square divided by L1, right? So N1 square R1 square by L1, N1 square R1 square by L1 will get cancelled. So now 4 into 4 is 16. Now 16 by 16 is 1, right? So electrical here, the ratio of the electrical power dissipated here, P2 by P1, right? P2 by P1 is equal to 1, right? That is P2 equal to P1. Here P2 is equal to P1. I will write it here. Okay, P2 equal to P1, right? That is electrical power dissipated is same. Hence option B is the correct answer. Okay, I hope everybody understood how to approach this problem or how to solve this problem. Okay, let's move on to the second question. 152nd. Here the question says a copper wire of length 40 centimeter, L equal to 40 centimeter. Okay, diameter 2 millimeter. Here they have given diameter of the copper wire, right? So the radius R equal to 1 millimeter, right, which is equal to 10 to the power minus 3 meter, and resistivity 1.7 into 10 to the power minus 8 ohm meter. So this is rho, right? Resistivity is equal to 1.7 into 10 to the power minus 8 ohm meter, forms a square frame if a uniform magnetic field B exists in a direction perpendicular to the plane of square frame and it changes at a steady state, at a steady rate, dB by dt is equal to 0.02 Tesla per second. Then find the current induced in the frame. We need to find induced current in the frame, right? Okay. So here induced current I is equal to induced EMF divided by R. R is resistance of the copper wire, right? Okay, so we need to find induced EMF and resistance of the copper wire. That's it. We will get the answer. Okay. So let us find induced EMF, then resistance. Okay. So induced EMF E is equal to rate of change of magnetic flux, right? So I am writing in magnitude. Okay, actually E equal to minus d phi by dt, right? So in magnitude, so it is d phi by dt. E equal to d phi by dt, right? So what is d phi? Change in magnetic flux, right? Dt is change in time. So magnetic flux phi is equal to B into A into cos theta, right? BA cos theta. So what is theta here? Theta is the angle between magnetic field vector and area vector, right? So what is the value of theta? So now we have to look at the question. Okay, in the question only they have given, so the direction of the here uniform magnetic field B exists in a direction perpendicular to the plane of the square frame, right? So this is the direction of the magnetic field, right? Isn't it? This is the direction of the magnetic field line. Here the magnetic field line is perpendicular to the plane of the square frame, isn't it? And here the magnetic field is perpendicular to the plane of the square frame, and area vector is also in the same direction of the magnetic field, isn't it? So area vector is also perpendicular to the direction of the perpendicular to the plane of the square frame, isn't it? Okay, so now both are in the same direction, right? So theta is equal to 0 degree, angle between B and A is equal to 0 degree, right? So phi is equal to BA, phi is equal to B into A, right? So now I can write induced EMF as E equal to here A into dB by dt, right? A into dB by dt. Here area is not changing, right? Magnetic field is changing. So E is equal to A into dB by dt. Okay. So now the first part is done, right? Now the second part, that is the resistance. Here resistance R is equal to rho into L divided by A, right? Rho into L divided by A is area of cross section of the wire, okay, pi into R square, right? So now substitute these two expression to this expression, okay, I, this formula. So now I is equal to E. E is A into dB by dt, right? Whole divided by R. R is rho into L divided by pi into R square, right? So that's it. Now you need to substitute the values, right? So now I is equal to, what is A? A is area of the square frame, right? Isn't it? Here the length of the wire is 40 centimeter. From this wire, so they made square frame, right? Isn't it? So each side of the square frame has length 40 centimeter, sorry 10 centimeter, right? 10 centimeter, isn't it? So here the area of this square frame is 100 centimeter square, right? 100 centimeter square is 10 to the power minus 2 meter square. So 10 to the power minus 2 meter square into dB by dt. Here dB by dt is 0.02, 0.02 whole divided by rho. Rho is 1.7 into 10 to the power minus 8 ohm meter. 1.7 into 10 to the power minus 8 ohm meter into length. Length is 40 centimeter, that is 40 into 10 to the power minus 2 whole divided by, here this one divided by pi into r square, right? So pi into r square is 10 to the power minus 3 squared, that is 10 to the power minus 6. So now solve this, okay, solve this, you will get induced current I as 9.3 into 10 to the power minus 2 ampere, okay, 9.3 into 10 to the power minus 2 ampere. So option A is the correct answer, okay. I hope everybody understood how to solve this question and how to approach this question, right? Okay, next question. Question number 153. An inductance of 200 by pi millihenry. See here inductance is given, right? L is given. A capacitance of 10 to the power minus 3 by pi farad, that is C is given, right? Here C is given. And a resistance of 10 ohm, R is given, are connected in series with an AC source 220 volt 50 hertz. The phase angle of the circuit is. So again this one is very simple question, okay. So we know the relationship between phase angle, inductive reactance, capacitive reactance and resistance, right? What is the relation? The relation is tan phi is equal to XL minus XC divided by R, right? So what is XL? Inductive reactance, XC capacitive reactance, R is resistance, right? So we know XL is omega into L, right? What is omega? Angular frequency, right? Okay. So now tan phi is equal to omega into L minus, what is XC? Capacitive reactance, that is equal to 1 divided by omega C whole divided by R, right? So omega is 2 pi f, right? 2 pi f. Here f is given, right? 50 hertz. So omega equal to 100 pi, right? Omega equal to 100 pi. So now tan phi is equal to XL. XL is omega into L. Omega L is 100 pi into L is 200 divided by pi. 200 divided by pi into 10 to the power minus 3, right? This is XL minus XC, that is 1 divided by omega C. 1 divided by omega. Omega is 10 to the power, sorry 100 pi, okay, omega is 100 pi and C is 10 to the power minus 3 by pi, okay, 10 to the power minus 3 divided by pi farad, right? So omega C is done, 1 divided by omega C is done, whole divided by 10, right? Whole divided by 10, resistance is 10 ohm, right? So now tan phi is equal to, so now solve this, okay, you will get 20, okay, 20 ohm, here you will get 10 ohm, 10 ohm, okay, 20 minus 10 is 10, 10 by 10 is 1, right? So 10 divided by 10, which is equal to 1. So phi is equal to tan inverse of 1. Tan inverse of 1. So which is equal to pi divided by 4. Tan inverse of 1 is pi by 4, that is 45 degree. Okay. So option B is the correct answer. Okay. Simple one, right? Okay, next question. 154th. A resistor 30 ohm. Here R is given, right? 30 ohm. Inductor of reactance 10 ohm. Inductor of reactance is XL. Okay. Inductive reactance 10 ohm. And capacitor of reactance 10 ohm, that is XC. Okay, XC. Capacitive reactance 10 ohm are connected in series to an AC voltage source E equal to 300 into root 2 sine of omega t. The current in the circuit is, so they are asking current in the circuit, right? That is RMS value of the current. Okay, whenever they ask the current in the circuit in AC from the AC chapter, they are asking RMS value of the current. Okay, so RMS value of the current, IRMS, is equal to VRMS divided by VRMS by Z. So now we need to find VRMS and Z. That's it. Direct question, isn't it? So VRMS, right? We need to find. Here the equation is given, right? E equal to root of equal to 300 into root of sine of omega t. So what is the general equation? Here what is the general equation? Let us write the general equation. Okay, for voltage, AC voltage, right? So the general equation is E equal to E naught into sine of omega t, right? E equal to E naught into sine of omega t. So what is E naught? E naught is maximum value of the voltage. Okay, E naught is maximum value of the voltage. Omega is angular frequency, T is time. Okay, so the maximum value of the voltage is 300 into root 2, right? You have to compare these two equations. Okay, so the maximum value of the voltage E naught is equal to 300 into root 2 volt, right? 300 into root 2 volt. Okay, now we got the value of maximum value of the voltage, right? Isn't it? Maximum voltage. We got the value of maximum voltage. So now we can easily find the RMS value of the voltage. How to find the RMS value of the voltage? We know the relationship between VRMS and maximum value of the voltage, right? VRMS is equal to V naught divided by root 2, right? So VRMS is equal to, here V naught is E naught. Okay, so V naught by root 2 is 300 volt. Okay, 300 volt. Okay, now we got the value of VRMS, right? So let us find the value of Z, that is impedance. Impedance Z is equal to root of R square plus XL minus XC whole square. Okay, R is given, right? 30 ohm. XL is given 10 ohm. XC is given 10 ohm. So XL minus XC is 0. 10 minus 10 is 0, right? And R square is 30 square. Root of 30 square is 30. That's it. So now Z is equal to 30 ohm, right? So now we can easily find the IRMS. IRMS is equal to VRMS, that is 300 volt, divided by Z, that is 30 ohm. So which is equal to 10 ampere. So the current in the circuit is 10 ampere. Okay. So option B is the correct answer, right? Next question. This one is very simple one, right? The question says a 220 volt input is supplied to a transformer. So this question is came from the transformer, right? The topic transformer. So this is the voltage in the primary coil, right? 220 volts input is supplied to a transformer. The output circuit draws a current of 2 ampere, that is the current in the secondary coil, at 440 volt, the voltage in the secondary coil, or EMF in the secondary coil, right? 440 volts. If the efficiency of the transformer is 80%, here let eta be the efficiency. Okay, efficiency eta is equal to 80%, right? So 80% divided by 100 is 0.8, right? The current drawn by the primary windings of the transformer, that is we need to find IP. Okay, let IP be the current drawn by the primary windings. So we know the efficiency, right? Efficiency is equal to output power by input power, right? So now output power eta, here output power eta is equal to, here eta is equal to output power, right? Output power is equal to ES into IS, right? Input power is equal to EP into IP. EP into IP. So now we need to find IP, right? IP is equal to, here ES into IS divided by EP into eta, right? So now we have the value of ES, IS, EP and eta. Substitute, that's it. So now IP is equal to ES is equal to 440 volts, right? 440 into IS, that is 2 whole divided by EP, that is 220 into eta is 0.8. So now solve this, you will get 5 ampere. Okay, current drawn by the primary windings is 5 ampere. So option D is the correct answer. Okay, question number 156. The electric field part of an electromagnetic wave in a medium is represented by Ex equal to 0, Ey equal to 2.5 Newton Coulomb cos of 2 pi into 10 to the power 6 radian per second into t minus pi into 10 to the power minus 2 radian per meter into x is at equal to 0. The wave is, here in option they said moving along x direction with frequency 10 to the power 6 hertz and wavelength 100 meter. Okay, frequency and wavelength is given, right? And the direction of the propagation of the wave is also given. We need to identify in which direction wave is propagating and the frequency of the wave and the wavelength of the wave. That's it. Okay, so let us write the general equation of this electric field wave. Okay, so from there only we will get to know in which direction the electric field wave is propagating. Okay, so the general equation here, Ey is equal to E naught into cos of omega t minus kx, Here omega is angular frequency, okay, t is time, k is propagation constant, x is in which direction the wave is propagating. Here the wave is propagating along positive x direction. Okay, if it is negative x direction, then here the sign would be plus. Okay, so the wave is propagating along positive x direction, right? Isn't it? So options C and D both are eliminated, isn't it? You have to choose the correct option between A and B. So for that we need to find the frequency and wavelength, right? So let us find the frequency. Omega value is given, right? Omega is 2 pi into 10 to the power 6. So omega is equal to 2 pi into 10 to the power 6 hertz. Sorry, 6 radian per second. Okay, 6 radian per second. 6 radian per second. So what is omega? Omega is 2 pi f, right? So 2 pi f is equal to 2 pi into 10 to the power 6 radian per second, right? So 2 pi will get cancelled. So f is equal to 10 to the power 6 hertz, right? 10 to the power 6 hertz. In option A and option B, yeah, the value of frequency is same, 10 to the power 6 hertz and 10 to the power 6 hertz. So we need to find the wavelength of the wave, right? So let us find wavelength. Here k value is given, right? Isn't it? K value, compare these two equations, right? So this is the value of k, right? K is pi into 10 to the power minus 2 radian per meter, right? K is pi into 10 to the power minus 2 radian per meter, radian per meter, right? So K is 2 pi by lambda, that we know, right? K is 2 pi by lambda, so 2 pi divided by lambda is equal to pi into 10 to the power minus 2 radian per meter. Okay, so pi will get cancelled, so the value of lambda is equal to 200 meter. 200 meter. So now we got the value of f and lambda, right? So in option B they have given moving along x direction, positive x direction, correct. Frequency 10 to the power 6 hertz, again correct, right? And wavelength 200 meter. So option B is the correct answer. Okay. So this one is again very simple question, dead easy question, right? So next question. 157th. A thin glass, refractive index of the thin glass is given 1.5. A thin glass lens has optical power of -5 diopter. Okay, -5 diopter. So this is the diverging lens, right? This is diverging lens. In air, its optical power in a liquid medium with refractive index 1.6. Okay, refractive index of the liquid medium mu m is equal to 1.6 will be. So we need to find the power of the lens. Okay, we need to find the power of the lens when the lens is immersed in the liquid. Okay, so for that we need to use lens maker's formula. That's it. From there only we will get the answer. Okay, so lens maker's formula is 1 divided by f is equal to relative refractive index, that is refractive index of the second medium with respect to the refractive index of the first medium, minus 1 into 1 divided by R1 minus 1 divided by R2. Okay, we need to use this formula. Understood? So now here when lens was in air, here 1 divided by Fa, the formula, lens maker's formula, 1 divided by Fa, Fa is focal length of the lens in air. 1 divided by Fa is equal to mu2 by mu1, that is refractive index of the glass with respect to air. Refractive index of the glass 1.5 divided by refractive index of the air, that is 1, minus 1 into 1 divided by R1 minus 1 divided by R2. Okay, R1 and R2 are radius of curvature. Okay, radii of curvature. We know that power is reciprocal of focal length, right? So I can also write this as 1 by Fa as Pa, right, which is equal to Pa, right? So now 1 by Fm is equal to, here Fm is focal length of the lens when the lens is immersed in liquid. Okay, so 1 divided by Fm is equal to, here relative refractive index, that is refractive index of the medium, refractive index of the glass with respect to the medium, okay, that is liquid. So refractive index of the glass, that is 1.5 1.5 divided by refractive index of the liquid, right, 1.6 minus 1 into 1 by R1 minus 1 divided by R2, right, which is equal to Pm, that is power of lens when lens is immersed in liquid. Okay, so now divide Pm by Pa. Okay, let's say this is the equation 2 and equation 1. Divide equation 2 by 1. Okay, divide equation 2 by 1. So I'm using another slide. Okay, okay, so now divide Pm by Pa. Here Pm is power of lens in power of the lens when it is immersed in liquid, right? Pm divided by Pa is equal to, here minus of 0.1 divided by 1.6, right? Minus of 0.1 divided by 1.6 whole divided by 0.5, right? So Pa is equal to minus 5 diopter, right? Isn't it? So Pm is equal to minus 5 into minus of 0.1 whole divided by 1.6 into 0.5. Okay, so now the power of the lens in liquid medium is equal to 0.625 diopter. Okay, 0.625 diopter. So this is the power of the lens when it is immersed in liquid medium. Okay, here the correct option is D. Okay, so in your question paper, so they have mentioned here minus 25 diopter and 25 diopter. Okay, those two are wrong options. Okay, so these two are the correct option. Okay, these two are the option. The correct option is 0.625 diopter. Okay, correct it. Next question, 158th. For the angle of minimum deviation, that is delta minimum, right? For the angle of minimum deviation of a prism to be equal to its refractive angle, that is prism angle. Prism angle can be called as refractive angle, right? The prism must be made of a material whose refractive index, that is, we need to find the value of mu, right? Look at the options here. They have given the refractive index lies between √2 and 1, lies between 2 and √2, is less than 1, greater than 2, right? So that is, you need to find the range of the refractive index, that is, you need to find the minimum value of the refractive index and maximum value of the refractive index. That's it. Okay, so we know the formula, right? The refractive index of the prism. Refractive index of the prism, mu equal to sine of A plus angle of minimum deviation delta m. A is refractive angle or angle of prism. Okay, A plus delta m by 2 whole divided by sine of A by 2. Okay, so now here delta m, that is angle of minimum deviation, is equal to A, right? According to this question, isn't it? So delta m is equal to A, right? So mu is equal to sine of A plus delta m, that is A plus A divided by 2, 2A by 2, 2 will get cancelled, it is just A, sine A divided by sine of A by 2. Okay, so now sine A is equal to mu into sine of A by 2, right? Isn't it? We can write sine A as sine of 2 into A by 2, right? You know, right? Sine 2 theta is equal to 2 sine theta cos theta, right? 2 sine theta cos theta, isn't it? So now take theta as A by 2. Anyway, 2 will get cancelled, so it will be just sine A only, right? So I can write sine A as sine of 2A by 2 or 2 into A by 2, right? Sine of 2 into A by 2, right? So which is equal to 2 sine A by 2 into cos A by 2, isn't it? So now here sine A, that is 2 sine A by 2 cos A by 2 is equal to mu into sine A by 2, mu into sine A by 2, right? So sine A by 2 will get cancelled. So mu equal to 2 cos A by 2, mu equal to 2 cos A by 2, right? Okay, so now the first part is done. Okay, I am dividing this question in two parts. So the first part is done, right? So now we know the relationship between angle of deviation, angle of prism, angle of incidence and angle of emergence, right? So that is delta is equal to, here delta is equal to I plus E minus A, right? I plus E minus A, right? So what is the condition for minimum deviation? The condition for minimum deviation is I equal to E, right? Isn't it? Condition for minimum deviation is I equal to E, isn't it? I equal to E. So I can write here delta minimum as I plus E minus A, I equal to E, right? Delta minimum is equal to A. So now 2A equal to 2I. So I equal to A, right? Isn't it? So we got this equation, right? Mu equal to 2 cos A by 2. So I can write 2 cos A by 2 as mu equal to 2 cos I by 2. Okay? 2 cos I by 2. A is equal to I, right? Isn't it? So let us find maximum value of the, minimum value of the refractive index, then maximum value of the refractive index. Okay. Here we want to find minimum value of the refractive index, right? If the value of the refractive index to be minimum, then the value of the I has to be maximum, right? Because the value of cos theta decreases as the value of theta increases, isn't it? So what is the maximum value of the I? That is 90 degree, isn't it? I max is equal to 90 degree, right? So mu minimum equal to 2 cos 90 by 2. 90 by 2 is 45 degree, right? 90 degree by 2 is 45 degree. So cos 45 degree is 1 by root 2, right? Right. So 2 by root 2 is root 2. So minimum value of the refractive index of the prism is root 2, right? So now we have found the minimum value of the refractive index, right? Let's find the maximum value of the refractive index. The maximum value of the refractive index, mu max, is equal to 2 cos. Here we want to find the maximum value of the refractive index, right? Here if we want to find the maximum value of the refractive index, then the value of the I has to be minimum, right? Isn't it? That is 0 degree. So 0 by 2 is 0 only. So mu max is equal to 2 into cos 0 is 1, so it is just 2. Okay, see here the refractive index will vary from root 2 to 2. Okay, sorry, lies between root 2 to 2, not varies from root 2 to 2, lies between root 2 to 2. So the correct option is B. Okay, I hope everybody understood how to solve this question. Okay, everybody understood how to approach. Okay, yeah. Next question, 159th. When light travels from one medium to the other of which the refractive index is different, then which of the following will change? Right, here light travels from one medium to the other medium, right? So that they are asking, which one will change? Frequency, wavelength, and velocity. Okay, so here apply Snell's law at this point. Okay, refractive index of the first medium into sine I, right? This is sine I, this is I, this is R. So mu1 into sine I equal to mu2 into sine R. So sine I divided by sine R is equal to mu2 by mu1, right? Mu2 by mu1. So which is equal to V1 divided by V2, right? V1 by V2. Again, which is also equal to lambda 1 by lambda 2, right? So from this we can conclude that if light moves from one medium to other medium, what happens? Velocity of the light changes, wavelength of the light changes, right? Frequency of the light remains same. Okay, frequency of the light remains same, only velocity and wavelength changes. In first option, what they have given? Frequency, wavelength, and velocity. Frequency does not change, so option A is wrong. Again, option B is wrong. Option C is wrong. Option D is the correct answer. Wavelength and velocity will change, right? Isn't it? Simple one, right? Dead easy question. Yeah. 160. Total internal reflection can take place only if option A says light goes from optically rarer medium, smaller refractive index, to optically denser medium. Okay, so here the light has to move from optically denser medium to rarer medium. Okay, then only total internal reflection can take place. Okay, optically denser medium to rarer medium, that is mu2 is greater than mu1, then only total internal reflection, that is TIR, can take place. So option A is wrong, right? Isn't it? Option B, light goes from optically denser medium to rarer medium. Yeah, option B is the correct answer, isn't it? Okay, next question. 161. By Huygens wave theory of light, we cannot explain the phenomenon of. Simple one, right? Isn't it? So by Huygens wave theory of light, we can only explain the phenomenon of interference, diffraction and polarization, isn't it? Huygens wave theory explains the wave nature of light, isn't it? Here photoelectric effect explains the particle nature of light. Okay, so option C is the correct answer. Okay, we cannot explain the phenomenon of photoelectric effect. Okay, question number 162. If two coherent sources are vibrating in phase, then we have constructive interference. Then we have constructive interference at any point P whenever the path difference is. Okay, so what is the meaning of coherent sources? Here, what is the meaning of two coherent sources, right? The coherent sources means the source which emits a light wave with same frequency, wavelength and phase or phase difference. Okay, so the path difference for constructive interference, here the path difference PD is equal to n into lambda. That's it. Direct question, memory based question. Okay, so option D is the correct answer. Okay, let's move to the 163rd question. Question number 163. Monochromatic light of wavelength 667 nanometer is produced by a helium neon laser. The power of emitted is 9 milliwatt, right? The power of the source is 9 milliwatt. Okay, power of the radiation is 9 milliwatt. The number of photons arriving per second, okay, number of photons arriving per second on the average at a target irradiated by this beam is. Here the wavelength of the light is given, right? Monochromatic light, that is the light has only one color, right? The wavelength is 667 nanometer, that is the value of the lambda, isn't it? So we need to find the number of photons arriving per second on the average at a target irradiated by this beam is. Okay, so now the power P is equal to energy of the one photon, okay, energy of the one photon into n divided by time t, right? T is equal to 1 second. We need to find n, right? E we know, that is hc by lambda, right? Power is 9 milliwatt, isn't it? Power is 9 milliwatt. So now here n, right, n is equal to power P divided by energy of the one photon, right? So now n is equal to, that is n divided by second, okay, number of photons arriving per second, right? Isn't it? n by second I can write, isn't it? Which is equal to P is 9 milliwatt, that is 9 into 10 to the power minus 3 divided by energy of the one photon. Energy of the one photon is hc by lambda, right? E is equal to hc by lambda, isn't it? What is h? H is Planck's constant, that is 6.66 into 10 to the power minus 34. Okay, C is 3 into 10 to the power 8 whole divided by lambda. Lambda is 667 into 10 to the power minus 9 meter, right? Isn't it? 667 into 10 to the power minus 9 meter. That is the value of wavelength of the monochromatic light. So you solve this, okay? If you solve this, you will get number of photons arriving per second is equal to 9 into 10 to the power, here 9 into 10 to the power, so this is 10 to the power minus 3, right? So 10 to the power minus 9 into 10 to the power, sorry, here 10 to the power 8 divided by 10 to the power minus 9, that is 10 to the power 17, right? 10 to the power minus 34 into 10 to the power 17 is 10 to the power 17, isn't it? So take 10 to the power 17 to the upper side, okay, numerator. So now this will be 10 to the power 17 into 10 to the power minus 3, that is 10 to the power 14. Okay, so from this you will get 90. Okay, if you solve this you will get 90 here. Okay, so 90 into 10 to the power 14 is here 9 into 10 to the power 15, right? So option B is the correct answer. Okay, so this one is very simple one, direct question, right? And some calculation is there, that's it. So next question, 164. A proton accelerated through a potential difference of 100 volt has de Broglie wavelength lambda naught. The de Broglie wavelength of an alpha particle accelerated through 800 volt is. Okay, so here this is the proton, right? It is accelerated through a potential difference 100 volt, right? Here the potential difference is 100 volt, isn't it? The proton, okay, moved from this point to this point. The potential difference is 100 volt, right? Isn't it? Its kinetic energy changed, right? Isn't it? So kinetic energy is equal to the electrical potential energy, right? Q into V, isn't it? Kinetic energy is equal to electrical potential energy. Q is charge of the proton and V is potential difference. Okay, okay, this one we understood, right? So we need to find the de Broglie wavelength of the alpha particle, right? So de Broglie wavelength lambda is equal to h divided by p. H is Planck's constant, p is momentum of the particle, right? So we know that momentum can be written as root of 2m into k e, right? Root of 2m into kinetic energy, right? So here the kinetic energy is equal to electrical potential energy, right? So momentum P can be written as root of 2m into q into v, right? So from this we can conclude that momentum is directly proportional to root of m into q into v. That's it. Okay, so now we can easily find the de Broglie wavelength, right? Isn't it? Here de Broglie wavelength of the alpha particle divided by de Broglie wavelength of the proton is equal to here momentum is directly proportional to root of m into q into v, right? Isn't it? So now here this will be equal to root of mp, that is mass of the proton, into qp, that is charge of the proton, into potential difference, let's say v1, okay, whole divided by root of m alpha q alpha into v2. Okay, mass of the alpha particle is equal to 4 times the mass of the proton, correct? And charge of the alpha particle is equal to 2 times the charge of the proton, isn't it? So lambda alpha divided by lambda p is equal to lambda naught, okay, which is equal to root of mp into qp into 100 divided by m alpha, that is 4 mp into 2 times qp, okay, into 800. So now solve this, you will get lambda alpha is equal to lambda naught divided by 8. Okay, so option D is the correct answer. I hope everybody understood this one. 165th, the Rutherford alpha particle experiment shows that most of the alpha particles pass through almost unscattered, while some are scattered through large angles. What information does it give about the structure of the atom? The option 1 says atom is hollow. Correct, right? Isn't it? Most of the alpha particle unscattered, isn't it? So this shows that here the atom has empty space, right? Isn't it? Lot of empty space, right? So option A is correct. Option B, the whole mass of the atom is concentrated a small center called nucleus. This one is also correct, right? So this is the gold foil experiment, right? Isn't it? Very few of the alpha particle got scattered, right? isn't it? So this indicates that the whole mass of the atom is concentrated a small center, isn't it? So that one is called as nucleus, isn't it? So second option is also correct. The third option, nucleus is positively charged, again this one is also correct. How he concluded that concluded this one? So because here the alpha particle, okay, scattered, okay, alpha particle scattered or moved back in 180-degree phase, okay, that is it exactly retraced its path, okay, retraced its path. So here from this he concluded that this nucleus is positively charged, okay, because alpha particle is positively charged, positive charges repels each other, right, isn't it? So from this he concluded that nucleus is positively charged. So option C is also correct. So option B, all of the above. So the correct option is D, okay, correct option is D. All of the above options are correct, right, isn't it? So next question, 166. An electron in the hydrogen atom jumps from excited state N to the ground state. The wavelength so emitted illuminates a photosensitive material having work function 2.75 electron volt. Phi is work function, okay, 2.75 electron volt. If the stopping potential of the photoelectron is 10 volt, the value of the N is, okay. So here the electron jumped from nth state to ground state, okay, 1, right. So when electron jumps from nth state to ground state, that is excited state to the ground state, the photon will release, right, energy will release, that is the photon, right, isn't it? So this light wave falls on the photosensitive material, right, photosensitive material, isn't it? So work function of the photosensitive material is given, and the stopping potential of the photoelectron is also given. We need to find the value of N, right? Okay, so first apply the photoelectric equation, right, Einstein's photoelectric equation. So energy of the incident photon, that is hc by lambda, is equal to maximum kinetic energy of the photoelectron plus work function of the photosensitive material, right? Here stopping potential is given, right, that is 10 volt. So maximum kinetic energy of the photoelectron is equal to stopping potential, right, isn't it? So energy of the incident photon hc by lambda is equal to maximum kinetic energy of the photoelectron, that is here 10 electron volt plus phi. Phi is 2.75 electron volt, right? So now the energy of the incident photon, right, energy of the incident photon hc by lambda is equal to 12.75 electron volt, right? So this is the energy of the incident photon, right? Or we can write this as En minus E1, okay, En minus E1. So now here En minus E1 is equal to 13.6 minus 13.6 divided by n square minus of minus, that is plus 13.6 divided by 1. So how we got this equation? We know that the energy of the electron in nth orbit, energy of the electron in nth orbit, En is equal to minus 13.6 divided by n square electron volt, right? We are taking the energy difference, that's it. So now here En minus E1 is equal to 12.75 electron volt, right, 12.75 electron volt. So 12.75 equal to here 13.6 into 1 minus 1 divided by n square, okay. So now solve this, you will get n as 4, okay. So option B is the correct answer, okay. Next question, 167. According to Bohr's model of hydrogen atom, option A says the linear velocity of the electron is quantized. Wrong, right? According to Bohr's model of hydrogen atom, angular momentum of the electron is quantized. Okay, here the angular momentum of the electron surrounding the nucleus, okay, mvr is equal to integral multiple of h by 2 pi or integral multiple of h cross. Okay, angular momentum is quantized, not linear velocity or linear momentum. Okay, so option A, B, C are wrong. Option D is the correct answer. Okay, next question, the direct question, right? This one, yeah. Next question, 168. Nuclear force exists between option A, neutron neutron, correct. Nuclear force exists between neutron neutron, proton proton, neutron proton. So option D is the correct answer. Okay, option D is the correct answer. Next question, 169. A nucleus splits into two nuclear parts. Okay, nucleus splits into two nuclear parts which have their velocity ratio equal to 2:1. What will be the ratio of their nuclear radius? Okay, so here initially nucleus is at rest. Okay, now it splits into two parts, right? Isn't it? Both parts will have different velocities. Okay, so apply conservation of momentum theorem. Why? Because there is no external force acting on our system. Okay, so now 0 is equal to m1 into v1 plus m2 into v2, right? m1 into v1 plus m2 into v2. Now consider only magnitude. Okay, so now m1 v1 is equal to m2 v2. Okay, m1 v1 is equal to m2 v2. So now m1 divided by m2 is equal to v1 divided by v2, which is equal to 2 by 1. Correct? We know that mass is directly proportional to volume, isn't it? Volume is directly proportional to r cube, right? So now I can write this as r1 cube divided by r2 cube, isn't it? r1 cube by r2 cube. So r1 cube by r2 cube is 2 by 1, right? So r1 divided by r2, r1 divided by r2 is equal to 2 by 1 to the power 1 by 3, or 2 to the power 1 by 3 is to 1. This is the answer. So option A is the correct answer. Okay, so next question, 170. The mass of a lithium nucleus is 0.042 atomic mass unit, less than the sum of the masses of all its nucleons. The binding energy per nucleons, but the binding energy per nucleon of lithium nucleus is nearly. Okay, here the mass of the lithium nucleus is given, right? That is delta m. Here delta m is equal to 0.042 atomic mass unit, isn't it? So let us find the binding energy of the lithium. So binding energy is equal to delta m, that is mass defect. Okay, this is mass defect, delta m into c square. So now binding energy is equal to delta m 0.042 into c square, right? So 0.042 atomic mass unit, isn't it? 0.042 atomic mass unit, right? I can write 1 into u, right, into c square. We know that 1 atomic mass unit into c square is equal to 931 mega electron volt, right? Mega electron volt. So binding energy Be is equal to 0.042, right? 0.042 into 931 mega electron volt, right? So now we need to find binding energy per nucleon, right? So binding energy per nucleon is equal to 0.042 into 931 mega electron volt divided by A. A is, in this case, 7, right? So binding energy per nucleon is approximately equal to 5.6 mega electron volt. Okay, solve this, you will get approximately equal to 5.6 mega electron volt. So option B is the correct answer. Okay, so next question 171. In order to prepare a p-type semiconductor, pure silicon can be doped with. Very simple one, right? Isn't it? If you want to prepare p-type semiconductor, you have to dope the trivalent impurities. Okay, trivalent impurities, that is boron, aluminum, right? So option B is the correct answer, right? Isn't it? Aluminum, right? So very simple one, right? The direct question, memory based question. Okay, 172nd questions here. This question says the resistivity of a semiconductor at room temperature is in between. Again, the memory based question. Okay, the resistivity of a semiconductor at a room temperature is in between 10 to the power minus 3 to 10 to the power 6 ohm centimeter. Okay, so option B is the correct answer. Okay, option B is the correct answer. Next question 173. When an impurity is doped into an intrinsic semiconductor, the conductivity of the semiconductor, again it's a memory based question, so conductivity of the semiconductor increases, right, when you dope the impurities into an intrinsic semiconductor. Why? Because the number of holes or the number of electrons increases, right? Isn't it? So option A is the correct answer, isn't it? So next question 174. The magnetic field dB vector, okay, so this is dB vector due to a small current element dl vector. Okay, this is dl vector at a distance r vector and element carrying current is. Okay, we need to find the equation, the correct equation, right? dB vector. So according to Biot-Savart's law, dB vector is equal to mu naught divided by 4 pi into I into dl vector cross r vector divided by r cube, right? In magnitude, I can write this equation as, dB as mu naught I dl sin theta divided by 4 pi into r square. Okay, so now the correct option is D. Direct question. Okay, question number 175. If E, M, J and G represent energy, mass, angular momentum and gravitational constant respectively, then the dimension formula of Ej square divided by m to the power 5 G square is same as that of. So we need to find the dimension formula of this one, right? Ej square divided by m to the power 5 G square. Okay, so we know the dimension formula of energy. Dimension formula of the energy is m L square, right? M L square T to the power minus 2. What is the dimension formula of the J? That is angular momentum. The dimension formula of the angular momentum is here m into v into r, right? M is mass, right? V is the dimension formula of the E is L into T to the power minus 1 into R. R is L. So L into L, L square, right? L square into T to the power minus 1. This is the dimension formula of J. And dimension formula of mass, M is M only, and the dimension formula of the gravitational constant. So this will be equal to m to the power minus 1, right? M to the power minus 1, L to the power 3, T to the power minus 2, right? The dimension formula of the gravitational constant is m to the power minus 1, L to the power 3, T to the power minus 2. Okay, so now here the dimension formula of this one, right? So this will be m L square T to the power minus 2 into J square, right? So this will be m L square T to the power minus 1 whole square divided by G square. G square is m to the power minus 1 L to the power 3 T to the power minus 2 squared into m to the power 5, right? M to the power 5. So now solve this, you will get m to the power 0, L to the power 0, T to the power 0. Okay, so we know that angle doesn't have dimension formula, right? Isn't it? So the correct option is A. Understood? Question number 176. A man throws a ball downwards from the roof of a tower of height 400 meter. At the same time, another ball is thrown upwards with velocity of 50 meter per second from the surface of the tower. Then at which height from the surface of the tower they will meet? Okay, so here this is the tower. Okay, this is the tower. A man throws a ball downwards from the roof. Okay, roof of a tower. The height of the tower is 400 meter. Okay, 400 meter. At the same time, another ball is thrown upwards with the velocity 50 meter per second. Okay, 50 meter per second from the surface of the tower. Then at which height from the surface of the tower they will meet again, right? They will meet. So let's say at height h, both balls will meet. Okay, at time t also. Understood? So now here let's apply the second equation of motion. Okay, second equation of motion here for these two situation. Okay, here the second equation of motion for this ball. Okay, h is equal to, second equation of motion, h is equal to u into t minus half gt square. Why minus here? Because the ball is moving in upward direction, acceleration due to gravity is in downward direction. So now h is equal to, u is 50 into t, right, minus half g into t square, right? So let's apply second equation of motion for this ball. Okay, so now this will be second equation of motion for the second ball. Okay, this is the first ball. 400 minus h is equal to ut, initial velocity of this ball is 0, into half gt square. Okay, why it is positive half gt square? Because the gravity and the velocity of the ball both are in same direction. Okay, so now h is 50t minus half gt square, right? Substitute this to, okay, substitute this equation, the first equation, to the second equation, right? So now here 400 minus h, right? H is 50t minus half gt square. 50t minus half gt square, minus into minus plus. So plus half gt square is equal to half gt square, isn't it? Here h is 50t minus half gt square, so minus 50t, minus into minus plus. So plus half gt square is equal to half gt square. So half gt square will get cancelled, right? So 400 is equal to 50 into t, right? So t is equal to 400 divided by 50. So this will be 400 divided by 50 will be 8, right? So t equal to 8 second. T equal to 8 second, that is at time 8 second. So both ball will meet, isn't it? We need to find h value, right? So now h equal to 50 into t. Let's use the first equation here, this equation. Okay, so 50 into t, that is 8, minus half g into t square, that is 10, into t square, that is 64. So h equal to 50 into 8 is 400, right, minus half into g into t square, right? Half into g, that is 10. 10 is, half into 10 is 5, right? So 5 into 64. 5 into 64. Okay, so here 5 fours are 20, right? 2. So 5 6 are 30. 30 into 30 plus 2 is 32. So 400 minus 320, which is equal to 80. 80 meter, right? The value of h equal to 80 meter. So here option C is the correct answer, right? Okay. So 177th question. An object is projected with a velocity of 20 meter per second. Here this is the initial velocity, okay, making an angle of 45 degree. The value of theta is 45 degree with horizontal. The equation of the trajectory is h equal to ax minus bx square, where h is height, x is horizontal distance, and horizontal distance a and b are constants. The ratio a is to b is, okay. So when the particle projected, okay, with an initial velocity u, making an angle theta with the horizontal, okay. So equation of this trajectory is y is equal to x tan theta minus gx square divided by 2u square cos square theta, right? So this is the equation of this trajectory, right? Isn't it? So now compare these two equations. Compare these two equations. Here y equal to h, right? A equal to, what is the value of a? Okay, what is a here? A is tan theta, right? So what is b? B is g divided by 2u square cos square theta, right? G divided by 2u square cos square theta. Okay, that's it. We need to find the ratio of a is to b, right? So a is to b, the ratio, right, which is equal to tan theta divided by g whole divided by 2u square cos square theta, right? So now a divided by b is equal to tan theta. Theta is 45 degree, right? So tan 45 degree is 1 divided by g. G is 10, right? 10 meter per second square, acceleration due to gravity, divided by 2 into u square. U square is 400, right? U is 20 meter per second, so u square is 400. 400, right, into cos square theta. Theta is, in this case, 45 degree, right? So cos square theta, cos 45 degree squared. So cos 45 degree squared is 1 by root 2 squared. 1 by root 2 squared is 1 by 2. Isn't it? 1 by 2. So 2 will get cancelled. 10 40s are 400. So the ratio A by B is equal to 40 by 1 or 40 is to 1. Okay, 40 is to 1 ratio. So option D is the correct answer. Okay, next question. 178. A block of mass M is in contact with the cart C as shown in the figure. This is the figure. Okay, the coefficient of static friction between the block and the cart is mu. Here, coefficient of static friction between the block and the cart is mu. Okay, the acceleration alpha of the cart that will prevent the block from falling satisfies. Okay, so here let us draw the free body diagram of this block. Okay, so how do you draw the free body diagram? First, draw the frame of reference. So now this is my frame of reference, y and x. Okay, so next isolate the body M. Then draw contact and non-contact forces, right? This is the contact force, right? And N is the contact force, friction is the contact force, and then the gravity mg, this is non-contact force, right? So this block is moving in horizontal direction with acceleration alpha, right? Okay, so now write the force equation or apply the Newton's second law of motion. Okay, so let's apply the Newton's second law of motion. Here summation of fx equal to m into ax, okay, and summation of Fy is equal to m into Ay. Okay, summation of Fx equal to m into Ax, summation of Fy equal to m into Ay. So what is the summation of Fx? That is all the forces, all the horizontal forces acting on this block, which is equal to m into acceleration of the block along the horizontal direction, that is alpha, right? So summation of Fx is here n, right? Is there any other force along the horizontal direction here? No, right? N, which is equal to m into A or m into alpha, right? So now summation of Fy equal to m into Ay. Here there are two forces along the vertical direction, right? The first one, frictional force. The second one, the gravitational force, isn't it? Right? Does block is moving along the vertical direction? No, right? Isn't it? So acceleration is 0. So m into Ay is equal to 0. That is, the frictional force is equal to mg, right? So F equal to m into g, isn't it? F equal to m into g. Here the block does not fall, right? Isn't it? Block does not fall. So the condition would be mu into n must be greater than or equal to F, right? Mu into n must be greater than or equal to F. Yes or no? So now mu into n is equal to, is greater than or equal to F, right? F is mg, right? F is mg. So now I can write this equation as here mu into n greater than or equal to mg, right? So n equal to ma, right? N equal to ma or m alpha. So now I can write mu into m into alpha, which is greater than or equal to m into g. M will get cancelled. So alpha is greater than or equal to g divided by mu. So this is the condition. So this is the condition for block does not to be fall. So now here the correct option is C, right? Alpha is greater than or equal to g by mu. Understood? Yeah. So next question. Question number 179. A bullet of mass m moving horizontally with the velocity v strikes a block of wood of mass capital M and gets embedded in the block. The block is suspended from the ceiling by a massless string. The height to which block rises is. So let us visualize the situation. Okay, here this is the block and bullet is moving with velocity v. Mass of the bullet is m. Here the block's mass is capital M. So when it strikes the block will rise by height h. Okay, we need to find the value of h. Here the bullet will embedded in the block. Okay, so here our system is block and bullet, right? So is there any external force acting on our system? No, right? So we can conserve the momentum and energy. So let's apply the conservation of momentum theorem. So the conservation of momentum theorem says that initial momentum is equal to final momentum. Initial momentum is mass of momentum of the bullet plus momentum of the block. Momentum of the block is 0. So momentum of the bullet is mv, which is equal to momentum of the block plus bullet, right? Final momentum is momentum of the block plus bullet, m plus m into v dash. Okay, v dash is the velocity of the block plus bullet. Okay, this is v dash. So now v dash is equal to mv divided by m plus m. Okay, half part is over. Next half part, that is we need to conserve the energy, right, to find the value of h, isn't it? So let's conserve the energy. Here apply conservation of energy theorem. Okay, initial total energy is equal to final total energy. Initial total energy is kinetic energy of the bullet only, right? Potential energy of the block is 0 and potential energy of the bullet is 0, which is equal to final energy, total energy. Final total energy is kinetic energy of the block plus bullet, right, plus potential energy of the block plus bullet. Potential energy of the block plus bullet, that is m plus m into g into h. Okay, m plus m into g into h. So now solve this. Okay, solve this. You will get h as v square divided by 2g into m divided by m plus m whole squared. Okay, so option A is the correct answer. Okay, 179 question is over. So this is the solution. This is how to approach this solution. Okay, so next question, 180. The angular momentum of a system of particle is conserved. So that is, they are asking when the angular momentum of a system of particle is conserved. So when net external torque or external torque acting on the system is 0, then the angular momentum of the system is conserved. Okay, so when no external force acts upon the system, so this is wrong, option A is wrong. Option B, when no external torque acts upon the system. Yeah, correct, right? So option B is the correct answer. So if you find this video very useful and helpful, please like, subscribe, okay, and share it to your friends. Thank you.